So this video is about all things dopamine. How does it work? How does it get broken down? How can we nutritionally support its production? And just a little bit of insight into its metabolism that you might find interesting as well. So first of all, what is dopamine? Well, it's a neuropeptide or neurotransmitter, and it helps us to experience motivation and drive. It helps us to want to put energy essentially into doing a task. So it can be any task that we do throughout the day that we need to achieve. If we have enough levels of dopamine, we'll get up and go and just do it and get it done. It can also be involved in things like sex and eating, because of course, if we don't have the motivation to do things, we won't be able to survive another day. So it helps with things like that. If you can imagine, if you don't have enough dopamine, you might experience feelings of what's the point? I can't be bothered. I just can't get up and go. Depression-like symptoms, essentially. If you have too high levels of dopamine, which by the way can actually happen as well, it might make you feel like you can't focus enough attention on a task and you can't hold your attention to one thing. You're sort of all over the place. Of course, there's much more to it, and I'm not saying that you have this or you have that, but it just gives you an insight as to what dopamine is involved in. So what's really interesting about dopamine is there are kind of two types, and I'm going to try to explain this the best way that I've heard. And that is tonic and phasic dopamine. These are the two types of dopamine that we have. So tonic dopamine is almost like the baseline level of dopamine that we have all the time. Whereas phasic dopamine is the dopamine that we release out in spurts throughout the day, depending on what we're doing. And the best analogy that I've ever heard is if you imagine it like, the ocean and waves in the ocean. The higher your tonic dopamine, which could be seen as the level of the ocean, the less you're going to notice the waves above it. Whereas the lower the level of tonic dopamine, or the lower level of the water, the more you're going to notice waves. So essentially, if your tonic dopamine or the stagnant level of dopamine is really high all the time, you might be less inclined to notice the little bumps of dopamine that you get throughout the day. Whereas if your level of tonic dopamine is lower, the phasic dopamine spikes will be noticed more. And you might find that you get little spikes of motivation and drive throughout the day. Interestingly enough, tonic dopamine, which again is the constant level of dopamine that we experience, if it's too high all the time, it will actually down-regulate dopamine receptors in a way of our body kind of coping with the higher levels of dopamine. So that's something to keep in mind too. So essentially, in a way, you actually want your tonic dopamine to be at a normal level and a lowish level, so that when you do get the spikes of dopamine throughout the day, they are much more noticed and our receptors are nice and sensitive to it, essentially. One little thing that I will point out here that's very interesting, and if you're interested in gene SNPs, this might fascinate you. We have different different enzymes that are going to help us to break down dopamine. And different ones will play a bigger or lesser role in what type of dopamine they're breaking down. So let me explain that a bit better. So when we're talking about the tonic dopamine, which is the constant level of dopamine that we have, throughout the day, all the time, that is going to be controlled and broken down mainly by an enzyme called the COMT enzyme. So if you have a SNP in the COMT enzyme, which is relatively common, I myself have it, it can potentially mean, it doesn't mean it's definitely going to be the case, and this is where gene SNPs are fascinating. It just can mean that you may have more of a tendency to have a slower activity of this enzyme, which essentially means that you might naturally have higher levels of tonic dopamine. So you have a higher level of the stagnant dopamine all day long. Another enzyme that's involved in this process too is the MOA enzyme, and that is involved more in the phasic dopamine breakdown. So let's say you have a SNP in this, which often makes this enzyme go a bit faster. It might mean that you break down your phasic dopamine or your bursts of dopamine throughout the day a little bit quicker. Interestingly enough, I have both of those, which is quite a fascinating balancing act. What we also want to understand about this too is that the role of methylation plays a big role in how much dopamine you actually, first of all, make and are able to break down. And that's because when we go through the methylation cycle, if you haven't heard of this, it's a cycle that occurs in almost every cell of the body, so it can play quite a big role in a lot of cellular functions. But essentially, methylation will allow for us to be able to produce neurotransmitters like dopamine. So what essentially we'll do is we'll take methyl groups from methylfolate and B12, and we will essentially pass it on and make this thing called BH4, which allows us to convert phenylalanine tyrosine into dopamine in the first place. So if your methylation cycle isn't working properly and you don't have enough methyl groups to be able to hand over to make BH4, you're going to have a hard time making enough dopamine. And as I said, you might feel symptoms of not having enough motivation and drive. So that's an interesting point to make here. Another interesting thing about this too is that when we are going through the process, let's say that we've eaten the precursor of dopamine, so we're trying to make dopamine in the cell, we've eaten the precursor of dopamine, which is phenylalanine, that gets converted to tyrosine, and then tyrosine gets converted to dopamine, and then dopamine can further converted into adrenaline and noradrenaline. And there are quite a lot of cofactors that we require in order for this whole process to work. The first one I pointed out was BH4, which we use, which we take from the methylation cycle. So essentially we require a functioning methylation cycle to work and to help us to produce dopamine from the phenylalanine that we ate in the diet. There are many other cofactors that we require as well, and I'm going to refer to my list because there's so many, but it's worthwhile keeping in mind that if you're not getting enough of these cofactors, you're going to have a really hard time not only producing dopamine, but then also breaking it down as well. So as I said, we require BH4, which, by the way, I will point out is inhibited, the production of BH4 is inhibited by oxidative stress. So you want to make sure you get on top of oxidative stress if that's an issue for you and you're noticing low levels of dopamine. SAMe, which is S-adenomethionine, and that is also produced by a functioning methylation cycle as well. Magnesium, B6, B1, NAD, FAD, copper, vitamin C, iron, folate, and B12. And again, a lot of these are actually used throughout the methylation cycle as well. But if you are low in any of these cofactors, you're going to have a really hard time making enough dopamine. Another thing I want to point out about nutrition is that vitamin A is what is going to stimulate receptor activity and sensitivity. So if you are low in vitamin A, you're going to have not enough, sensitivity at the receptors for dopamine. So let's go back and think about the neuron. Let's say we've released out dopamine. We've synthesized it first, and we've released it out from the neuron. It then has to bind to a receptor. And it's vitamin A that helps us to increase the sensitivity at those dopamine receptors so that we can essentially feel the effect of dopamine. So just as a really simple and quick recap, when we want to make dopamine, we take phenylalanine, which we get from our diet. It is an essential amino acid. We can then convert that to tyrosine, and then from there we convert tyrosine to L-DOPA and then dopamine can further get converted into adrenaline and noradrenaline. We require many cofactors in which we can get from our diet. We also require a functioning methylation cycle, which will use methylated folate and B12, hand over a methyl group, and that will help us to make BH4, which will then help us to also convert that phenylalanine to dopamine, which helps us to feel more motivation and drive. And what's really interesting is that if you were to notice that you are low in one of these cofactors, this can disrupt this process. So I encourage you to check your numbers on all of these cofactors. Make sure that you're getting them from your diet, and also make sure that you are getting enough phenylalanine, the precursor to dopamine, in your diet. And this is really abundant in animal food. So anyway, I hope you found this interesting.